Welcome to This Explainer. Today, we're pulling back the curtain on Cambridge AS and A-level mathematics, specifically targeting syllabus 9709 mechanics. Listen, if you've ever felt like achieving top marks in mechanics requires some kind of academic magic, well, you're actually in the right place. Think of structural frameworks as your magic spells. If you cast the right spell, you're going to extract maximum marks. So, we're going to decode the examiner's playbook for one of the most notoriously tricky topics out there, Newton's third law. Right off the bat, let's look at this exact quote, which comes directly from a senior Cambridge examiner. This really sets the high stakes for our analysis today, doesn't it? It's a massive statement. The difference between a totally average grade and an absolutely exceptional one often hinges entirely on this single area of physics within your math syllabus. It's not just about reciting that every action has an equal and opposite reaction. No, it's about how deeply you actually understand the mechanics architecture behind that statement, and more importantly, how effectively you prove that understanding on paper. Here is our roadmap for today. We'll hit 1, the A-star difference, 2, core theoretical principles, 3, the procedural framework, 4, critical analysis, and 5, top examiner warnings. Let's jump right in. Starting with section 1, the A-star difference, and shifting your academic approach. Okay, so a super common trope students fall into is what we call superficial breadth. They basically try to brain dump every single formula they've ever memorized onto the exam paper, just praying that something sticks. But look at the stark contrast here. The assessment framework explicitly prioritizes analytical depth over a superficial breadth of scattered facts. That means how deeply you analyze a specific problem matters way more than how much ink you put on the page. Examiners are hunting for logical, structured reasoning. They definitely aren't looking for a shotgun approach to physics equations. Moving on to section 2, core theoretical principles and the mechanics architecture. Now, what's really fascinating about this slide is how it visualizes the assessment objectives. Notice how the objectives for Newton's third law aren't just one flat category. They are explicitly mapped across 3 distinct cognitive domains: knowledge and understanding, application, and analysis. You can't just define the law, you actually have to apply it to a really complex scenario and then analyze the resulting forces. If your answer only demonstrates basic knowledge, you're literally leaving 2/3 of the marks on the table. Oh, and before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. This brings us to the theoretical architecture of your answers. Your foundation absolutely must rest on precise definitions and a crystal clear understanding of causal relationships, like which specific force is causing which specific reaction. But here is the ultimate secret weapon. Principal examiner reports consistently highlight that candidates who integrate cross-topic connections achieve significantly higher scores. Don't view Newton's third law in isolation. Connect it to kinematics or energy principles whenever the question allows. That cross-topic integration is a massive, flashing neon signal to the examiner that you are operating at an A-star level. So the absolutely crucial takeaway here is understanding the method mark strategy. This is a grading framework where marks are awarded for your systematic analytical process, not just for getting the final numerical answer right at the bottom of the page. Examiners actually reward your intellectual journey, meaning the procedure itself, how you set up the equations, how you balance the forces, is your most valuable asset. Honestly, even if you make a tiny, silly calculator error at the very end, a flawless method is going to capture the vast majority of the marks. Now for section 3, the procedural framework. Let's execute the perfect answer. Knowing that the process is everything, we can build your theoretical understanding into a strict, standardized 5-step sequence. You must use this to systematically process every complex mechanics question. Step 1, identify key elements by extracting the relevant data from texts and tables. Step 2, select and apply the relevant principles. Step 3, execute your analysis with exceptionally clear working and notation. Step 4, verify your results to check for reasonableness. And Step 5, present your answer with the correct terminology. Guys, this is a totally non-negotiable workflow for complex problems. To help you lock this in, I highly recommend inventing a personal memory hack. Create a mnemonic using the first letters of these key framework terms: identify, apply, execute, verify, present. Maybe something like, intelligent analysts execute very precisely. Honestly, whatever works for your brain. Having this mental checklist ensures you can instantly recall this framework during the intense stress of an exam, ensuring you never skip a vital mark-earning step. And hey, stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to Ace the Exams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Let's move into Section 4, Critical Analysis and Evaluation for Higher Order Problem Solving. Once your basic solving framework is locked in, you need to tackle the higher order assessment objectives. These demand that you critically evaluate the quality of the evidence right in front of you. When you evaluate a scenario, you've got to mentally split the problem into 4 quadrants. First, check for the limitations of the model. Second, assess the assumptions made, like, are you assuming a string is light and inextensible, or a pulley is perfectly smooth? Third, explore alternative interpretations. And fourth, weigh the effect all of this has on the final conclusion. Making justified recommendations based on this multi-layered evaluation is exactly the magic that pushes a solid paper into that top-tier A-star territory. Finally, Section 5, Top 3 Examiner Warnings. Let's talk about avoiding the trapdoors. For our final stretch, we're shifting into defensive strategy. We've done deep dives into the principal examiner reports. And you know what? There aren't 100 different ways students fail. There are exactly 3. 3 massive repeating pitfalls that consistently drop candidates out of the A-star bracket year after year. Let's break down these 3 trapdoors. First up, confusing cause and effect. In Newton's third law, mixing up the action force with the reaction force on your free body diagram is absolutely fatal to your working. Just don't do it. Second, forgetting format and presentation conventions. This means failing to use proper headings, correct terminology, and clear annotation. Think about it. If the examiner can't follow your logic, they literally can't award you method marks. And third, providing generic answers. Strict adherence to clear causal relationships and precise formatting is absolutely non-negotiable. We leave you with this final, critical alert, straight from the marking rooms. The absolute classic mistake is just copy-pasting a generic definition that you memorized from a textbook without actually applying it to the problem at hand. Ask yourself, are your conclusions generic, or are they ruthlessly linked to the specific scenario in front of you? I want you to take this question and apply it as a strict filter for your very next practice paper. If an examiner read your final paragraph, would they know exactly what physical system you were analyzing, or could your answer apply to a dozen different questions? Master the specifics, and the A-star follows. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder: subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.